Namaskar Mitro, myself Parmar Chetan, and today I am going to discuss about data structure. Now from this lecture we are introducing a new subject, data structure, and today I am covering introduction section about data structure, what is data structure, types of data structure, what is categories, and each and everything about introductions. I am trying to covering it. Okay, so now let's see what is data structure. First, introduction about data structure. So basically we can see that data structure is the combination of two words, data plus structure. So first we can understand what is actually a data. So we can say that it is a collection of raw fact. It's known as a data, and that data will be set into a proper structured way. Then it's become a data structure. Okay. Now, in technical terms, what is a data structure? So it's a data structure is a way of storing a data in a computer so that it can be used efficiently and it will allow the most efficient algorithm to be used. Means we can say that our main purpose of data structure is to store data in a computer. In that format we can fetch the data and search the data in efficient way. Okay. Data structure is a representation of logical relationship existing between individual element of data. We can also say this logical relationship between the individual element of data. So from this analysis, we can say that our data structure plus algorithm, if we combine these two things, then it becomes a program. Algorithms, you all of are aware that main purpose of this algorithm to solve a particular problem in a stepwise format, and that stepwise format is following some data structure. Then it's known as a program. Okay, clear? Now, classification of data structure. Basically, this data structure will be divided into two parts. The first is known as a primitive part, and second one is known as a non-primitive part. In simple term, we can say that primitive part is that part which already exists, and non-primitive part is that part which will be created by using this primitive structure. So it's a non-primitive part. See, in this diagram, I am trying to bifurcate the primitive section, non-primitive section also. Here in primitive section, you can see that this is the basic types of any programming language. It may be an integer, floating point number, character, pointer. These all are under the primitive types. Okay. And in non-primitive type is basically divided into three sections: array, list, and file. You heard about this array. Array is again storing a multiple data in a single name. List is again type of collections. File is again collections of multiple data. And again this list will be divided into linear list and non-linear list. And this linear list contains stack and queue, and non-linear list contain graph and tree. Okay, so this is the basic classification structure of data structure. We will be see in a further videos about each and every component of these data structures. Okay, in this video we covering primitive, non-primitive, what is linear, what is non-linear, and then further videos, in future videos we will cover with stack, queues, graph, trees, and everything which is under the data structures. Okay, so now move ahead. Primitive. Now see what is actually a primitive type. So it's a primitive data type structure used to represent the standard data type of any one of the computer programming language. As we can see here, these all are the types. If we are considering C programming language, so there is integer is available. If we are following a .NET programming language, again integer is available. If we are following a Java programming, so again integer is available. So it is all other data type of any programming language. Okay, this cover in the primitive data structures. Then maybe a variable, arrays, pointers, structure, union. These all are the examples of the primitive data structures. So in normal terms, we can say that it is a basic structure and are directly operated upon by machine instruction. Because these all things, variable, array, pointer, structure, union, is working with the machine instruction. So that's why it is all under the primitive types. Okay. Then non-primitive types. In non-primitive type is a sophisticated data structure types, and we can say that it is a derived from primitive data structure. As I earlier said, if you want to create any non-primitive data type or data structures, you must have to use a primitive data structure, any one of the primitive data structure. That's why here we can say that here this considered as a non-primitive. Linears, non-linear, stack, queues, graphs, and trees is again these portions of these earlier graphs. Okay, so now move ahead. Now it's a linear data structure. So what is this linear data structures? So we can say that linear data structure can be constructed as a continuous arrangement. So you can focus on this word, continuous arrangement of data in a memory. That we can say that the data will be stored in a linear fashion, one by one sequential fashion. Data will be stored in a memory. It can be constructed by using array data types because array is following the concept of linear data structure. That's why it will be constructed using array data types. In the linear data structure, the relationship of adjacency is maintained between a data element because all data will be stored in a sequential wise. So each and every data have considering the relationship with its prior and prefix data. Okay, that's why here is adjacency is maintained in a linear data structures. So commonly used linear data structures are stack, queue, and linked list. These trees is commonly used in a considered in a linear data structures. Okay. In a future video, we separately creating stacks, how to create stacks, queues, and linked list. Okay. Then non-linear data structure. So same way, linear data structure, so non-linear data structure. In this structure, data item is considered with several other items. So we can say that it is not following the linear fashion. That's why it's not arranging in a sequential manner on data. So FSI is randomly your data will be stored and randomly your data will be picked up. Okay. The commonly used non-linear data types are trees and graphs. Okay. These two data structure is following the non-linear data structures. Now, what is the exactly difference between the linear data structures and non-linear data structure? Here in tabular form, I have tried to explaining it. What is this exactly? In linear, every item is related to its previous because it is a sequential manner. Okay. In a non-linear, every item is attached with many other items because it is following a hierarchical structure, not a linear structure. Second, in linear, data is arranged in a linear sequence. In non-linear, data is not arranged in sequence. This is an unsequential manner data will be stored. In linear, data item can be traversed in a single run because single item you can fetching all the data element in a sequential manner, sequence by sequence. But in non-linear, it is not possible by single run. Okay. Linear can be implementation is very easy because we know aware of if you are aware about the array, it will be easy. how to create arrays and how to fetch element. Just you can providing an indexing number and it will be fetching a data. If you want to store any element, you just provide indexing number and value, so it will be stored array element. Okay, but in non-linear, the implementation is little bit difficult as compared to a linear data structures. Here just mentioning about types. So linear contains array, stack, queue, linked list is the types of linear, and trees and graphs is under the non-linear data structures. Okay, then what are the operations performed on these data structures? What we can do with these data structures? The first operation is add an element. We can add any element in non-linear also and linear also. Same way we can delete an element from the data structures. Same traverse. Traverse means what? We can move in data structures. If suppose if there is a tree, so in tree we can traversing from root to leaf also, leaf to root also, and siblings also. So any manners you can traversing there in trees. Then sort of the list of the element, you can sorting the element of the data structures in a meaningful order. And last one is a search. If you want to search any of the item from the list, then you can be search using this searching facility. So there are basically 5 operations you can perform on data structures: adding element, delete an element, traversing, sorting the list of element, and search for the data elements. Okay, so here in this video I am trying to just give a brief introductions about the data structure. So guys and friends, thank you so much for watching this video. If you like this video, you can press the like button, you can also press the bell button and subscribe my channels. If you want to you want to get a notifications of my new upcoming videos, then you can press a bell button. So whenever I am uploading a new videos, you can get a message or notifications from the YouTube's. Thank you so much once again. Thank you so much and have a good day.